Hello everyone, this is a video recording for the Chapter 2 test review, so let's go ahead and begin. Problem number 1 is asking us to evaluate the function at f is equal to 0. So let's go ahead and plug this into this function f of x and plug in 0 everywhere we see x. So f of 0 is going to equal to 2, and again we're replacing everywhere we see x with 0. So 0 squared minus 5 times 0 plus 6. Following the order of operations, we get 0 here minus 0 plus 6. And so very quickly we know that f of 0 is going to give us a positive 6. Same thing we can do with g of negative 2. Now we're going to use g of x function to plug in negative 2 into that function. So when we do that, we get negative 3, replace x with negative 2 plus 1. So order of operation tells us to multiply first, so let's go ahead and do that. We get positive 6 plus 1, which in turn gives us 7. So g of negative 2 is equal to 7. Now similar concept, except now we're plugging in 3x rather than just a specific value. So let's go ahead and do that. Again, we're using f of x this time, so we're going back to the 2x squared minus 5x plus 6. So let's replace x with 3x squared minus 5 times, and again we 3x plus 6. 2 times, well, first of all we have to follow order operations by taking the exponent, which gives us 2 times 9x squared minus 5 3 times 3x plus 6. Followed by that we can actually multiply them, so we'll get 18x squared minus 15x plus 6. And since I can't combine any like terms or put any terms together, I'll just leave my answer as 18x squared minus 15x plus 6. Same thing, except now I'm using g of x, and I'm gonna replace everywhere I see x, I'm gonna replace it with x minus 1. So let's go ahead and do that. You get negative 3 x minus 1 plus 1. So using distributive property, we can distribute the negative 3, which then in turn gives us negative 3x plus 3 plus 1. And finally we get negative 3x plus 4. So that's the first 4 problems. Now from notes that we did on section 5.7 and 5.8, we know that we can take the function of g and replace it with, in this terms it's talking about f taking g of 2, and then again we can write it different ways, so this is one way of writing it. And what it's asking us to do here is finding out what g of 2 is first, and then taking that value and then putting that in f of x. So let's go ahead and do that. So first thing I would do is find what g of 2 is. So g of 2 is going to be negative 3, replace x with 2 plus 1, which then in turn gives me negative 6 plus 1, which is negative 5. So now I know what g of 2 is. I'm going to use f of negative 5, and then from here I would substitute that into place of x, so it'd be negative 5 squared first, minus 5 times negative 5 plus 6. So this allows me to use order of operations, which gives me 2 times 25 minus 5 negative 5 plus 6. That in turn gives me 50 plus 25 plus 6. So 50 plus 25 is 75. 75 plus 6 would be 81. F plus g, just asking us to take f of x and add g of x together. So f of x would be 2x squared minus 5x plus 6, and you are adding negative 3x plus 1. So now I do have like terms. I have a negative 5x and I have a negative 3x, and I do have a couple of constants that I can put together. So my final answer will be 2x squared. Negative 5x plus a negative 3 will be negative 8x. Positive 6 and a positive 1 will give me positive 7. Similar concept, except this time I'm subtracting. So again, f of x will be 2x squared minus 5x plus 6 minus, remember to put that parenthesis, and then the g of x, which is negative 3x plus 1. Do not forget to distribute the negative, so make sure you distribute the negative into that parenthesis, which in turn gives us 2x squared minus 5x plus 6 plus 3x and then minus 1. Combining like terms, I do have a couple of things that I can put together. So doing that gives me the following: 2x squared, negative 5x, positive 3x gives me negative 2x, and then positive 6 plus a negative 1 would be positive 5. G times or f times g would be just multiplying f of x and multiplying g together. So again, f of x would be 2x squared minus 5x plus 6, and again I'm multiplying that by negative 3x plus 1. So I'm using distributive property, and I'm actually going to go this direction just because I have to multiply less things that way. And I should be doing that with 1. So it'll be 1 times that, then 1 times that, and then 1 will be also multiplied by that. So let's go ahead and see what we get. Negative 3x times 2x squared will actually give us a negative 6x cubed. Negative 3x times a negative 5x will actually give us a positive 15x squared. And a negative 3x times positive 6 will give us negative 18x. So 1 times 2x squared will be positive 2x squared. 1 times negative 5x will be negative 5x. And then 1 times 6 will be positive 6. So as you see, we do have like terms. We have a couple x squares that we can combine. Also negative 18x and negative 5x also can be combined. So our final answer is going to be negative 6x squared. When you take positive 15x squared and a positive 2x squared, you will actually get positive 17x squared. And I do apologize, that should be cubed. Then negative 18x minus 5x, again, signs are the same, so you're going to combine them and keep the sign, so you get a negative 23x and then plus 6. So as you see with number 9, it's asking you to take the function of g and input it or place it in the function f. So what we have to do is take g, which is negative 3x plus 1, and everywhere we see x in f, we're going to put negative 3x plus 1. So we get the following: remember our f of x is 2 times x squared, which means we're going to replace x with negative 3x plus 1, and we're going to square it. Then we have minus 5, again replace x with negative 3x plus 1, and then plus 6. Then we get 2. When I square this, the negative 3x plus 1, I get positive 9x squared. I will also get negative 6x, and then plus 1. And then we have negative 5 times negative 3x plus 1 plus 6. So from here I can distribute the 2, and at the same time I can distribute the negative 5. So let's see what we get from here. 2 times 2x would be 18x squared. 2 times negative 6 would be negative 12x, and plus 2. Multiply negative 5 and negative 3 will give you positive 15x. Multiplying negative 5 will be negative 5 times 1, and then plus 6. As you can see, we do have some like terms, a couple x's we can put together, and there are actually 3 constants that I need to put all of that together. So our final answer is going to be 18x squared. Negative 12x plus 15x will give you positive 3x, and then positive 2 plus negative 5 will give me negative 3. Negative 3 plus that will give me positive 3. And that will be my final answer for f of, or the fog, or the function of placed in the function g. In this case we do have the opposite, so now I'm taking the function f and I'm placing that in the function g. And remember, my function g is negative 3 plus 1, so everywhere we see x, which we only see it once, we're going to replace that x with the function of f of x, and we get negative 3, and again our f of x function is 2x squared minus 5x plus 6, and then we have plus 1 from the g. Well, here we have to distribute the negative 3, so distributing the negative 3 inside the parenthesis, we get the following: negative 6x squared plus 15x, and then minus 18 plus 1. The only 2 things I can combine is the 2 constants at the end, so we get negative 6x squared plus 15x, and then minus 17. So that's problem 1 through 10. So that gives us the answers 1 through 10. Alright, 11 through 15, use the function here on your right. So we have to use everything we see on the right using that function to answer these questions. So the first one, number 11a, says f of negative 2. Well, what this is saying is that if you were to take x as negative 2 and plug it into the function, what would be your output? So all we have to do is go ahead and look at where negative 2 here. Negative 2 is here, so my output would be there, which actually gives me my y value. So my y value, if I plug in negative 2, my y would be also negative 2. Now, f of 0 states that find where x is 0, go down, and where it hits the graph, that's your y output. So in our case, that looks like negative 1, negative 2, negative 3, and most likely negative 3.5. So that's I'm going to put as my answer, negative 3.5. And last but not least, f of 1, well, 1 is here. Notice that graph is actually going through that, so your output actually here would be where y is 0. So my answer would be 0 there. So that takes care of the inputs and outputs. Now the domain, if you recall, domain represents the x values. So I have to ask myself, okay, where is this function go from on the x-axis? So notice it starts over here and it goes all the way to about there. So my function should be in between those yellow lines. So the yellow highlighted area, that's where my x's go from left to right. The first x, as you can see, it seems like it's going to be -1, 2, 3, 4, probably 4.5. It does include it, so we're going to put a bracket there. So it'd be -4.5, comma, and then it will be +1, and it looks also like it's 1.5. And again, since it's closed, it's going to be bracket. Now looking at the range is your y values. So you look at from where to where does my graph go on the y, and as you can see, it goes from there to there. So it's all in this area here that I'm highlighting. That's the range that goes from top to bottom. Now it looks like it's a little bit off, but I'm gonna round it off. So it looks like the first one is probably 1, 2, 3, 4, 5. It goes down 5, so it'd be -5, and it goes up. I'm gonna call it 3, even though it may look like it's just slightly above 3, but I'm just gonna call it 3. So the range would be -5 to +3. That's how as far as the function goes. Now since the circles are closed, that means it does include them. Now we have to find the maximum. Notice there is one maximum. It's here, and it looks like it's at -2, -2. So I'm going to put my maximum at -2, -2. I do have a min, which means it's somewhere here, and it looks like it's at 0 and 1, 2, 3.5. So it will be at 0 and -3.5. So that's where my minimum is. And there's only 2 of them. Okay, increasing intervals is where the graph is going up. If we're going from left to right, it's like riding uphill. So as you can see, my first section, the increasing portion will be from here to there, and my second section will be from here to there. So I have to label those intervals. So let's start with the first one, what we see highlighted in green. It starts about 1, 2, 3, 4, 4.5. So it starts at -4.5. And it goes up to, looks like -2. It says there's 2 intervals, we're gonna say, and it starts at 0 and goes all the way to about 1.5. Well, the other section, the decrease, if you will, okay, the section that we're actually decreasing or going down, would be this section. It starts from here, goes to there. And so let's go ahead and write in our interval there. It starts at -2 and goes all the way down to 0. And then it starts to increase again. Is this function one-to-one? Well, remember, for us to know if it's a one-to-one function, we have to do the horizontal test. And very clearly, hopefully very clearly, you can see that if I draw a horizontal line, there's going to be an issue. It crosses there, there, and there. Therefore, there are 3 places where it intersects. Therefore, this is not, or no, this is not a one-to-one function because it does fail the horizontal test. It is a function, it does pass a vertical test, but to know if it's one-to-one, it has to pass also the horizontal test, which it does not. Moving on to problem number 16, it says graph the following and list the transformations. Notice they give you the parent is given. So here's my parent. That's my parent function. In this case, it's x squared. So that's your parent function. The question is, okay, what are the transformations from the parent to the new function that they give you? Well, there's a couple of things you need to pay attention. That does something to the function. The +2 does something to the function. And the -1 does something to the function as well. So if I list those things, the negative in front of the parenthesis will give a reflection about the x-axis. So it's going to reflect about x-axis. Also, the +2 inside the parentheses will move the function. Remember, inside lies, so if it says +2, it's actually going to go left 2. So this is going to be 2 units left. And the outside -1 will actually shift this vertically, so it's going to take it to 1 unit down. So that's what I expect to see on the test when you see these type of problems. So here's the parent function again. This is the parent. And the function is actually square root of x. So what we need to do is we need to look, well, how is that going to be affected by my new function? So as you can see, there are a couple of things. You have the negative. That's going to do something with that. And you have a +4 on the outside. That's also going to do something to that function. So let's see what happens. The negative in front is going to reflect. Again, this is going to be a reflection. About the x-axis. And the +4, since it's on the outside, it's going to move up and down. So it'll be 4 units up. And that will be our information about the transformations that happen from the parent to the function they gave you. Similar things, number 18, it's asking you the same thing. List the transformations from the graph from f of x to the new graph they give you. So in this case, that 1/2 in front will have a vertical stretch by factor of 1/2. We will also have one unit left, 1 unit right, because inside lies, and 2 units up. Now on B, notice we have a +3 inside, and remember it lies 2, so even though it's multiplying the 3, it's actually going to be not a stretch but a shrink. And remember, this is going to be a horizontal shrink. Shrink by a factor of 1/3. Remember from the notes that we have to put 1 divided by C, C or B or whatever the variable is in front there. So it's actually 1/3, not factor of 3. And because you see a -5 on the outside, this would be 5 units down. And last but not least, for this type of problems, again, the negative and the 2 are going to have an effect on that. It's going to reflect. The negative is going to be reflection. X-axis. It's going to have a vertical stretch by 2 and 25 units up. So that's what we have for that problem. So finding the average rate, remember, if you're getting confused by this formula, remember what I said, go ahead and use this one, x2 minus x1. Average rate is just slope. So it should be y2 minus y1 divided by x2 minus x1. This is just slope. So make this x1, make that x2. And to figure out your y's, all you have to do is plug in your x's to get your y's. So if x is -2, when I plug in -2 into here, I get 2 times -2, which is -4, plus 5 would be +1. So that gives me the first point. The second x would be 1. Again, plug that into there. It would be 2 times 1, which is 2, plus 5, which would be 7. So I got my second point. Now use this equation, how to find the slope, except label your points. Make this x1, y1. This will be x2, y2. And you get the following. 7 minus 1 divided by 1 minus a -2, which is equivalent to 6 divided by 3, which is 2. So my answer here will be +2. Similar concept, but this time I'm plugging in -5 and +3. So first, to get your first point, plug in -5 into the function. So -5 squared will be 25. So again, we'll get +25. Then we have 4 times a -5, which actually gives me -20. And then minus 3. So 25 minus 20 will give me 5. And 5 minus 3 would be 2. So my output would be 2 there, or my y would be 2. In this problem here, I'm going to plug in 3. So now when I plug in 3, I should get an output as well. So let's see what that is. When you plug in 3, 3 squared would be 9, plus 4 times 3, which is 12, and then minus 3. And now we have 9 plus 12, which is actually 21, and 21 minus 3 would be 18. So now using our formula from here, we get 18 minus 2 divided by 3 minus a -5. So now that gives us 16. Well, that becomes addition, so that would be 8. And 8 goes into 16 2 times. Sorry for that. That was the bell when I was recording this. So let's continue. It says find the different quotient. So remember, this is the problems that we did in class when you take f of a, you figure out what f of a is, and you take f of a plus h, figure out what that is, and then take f of a plus h minus f of a divided by h. So let's start with figuring out what f of a is. F of a is going to be 3a plus 10. F of a plus h is going to be 3 times a plus h plus 10, which then gives me 3a plus 3h plus 10. So now, since I know what those are, I'm going to go ahead and subtract them. So I'm going to take 3a plus 3h plus 10 minus, remember, put the parenthesis there, 3a plus 10, and divide that whole thing by h. So take the negative and distribute. You get the following: 3a plus 3h plus 10 minus 3a minus 10 divided by h. Notice things start to simplify or cancel out. So all you're left with is 3h divided by h, which means I can cancel out the h's. So my answer will be 3. Similar concept. This time I'm going to find f of a. So f of a is going to be 2a squared. So that was easy. Now f of a plus h is going to be a little bit more difficult because we're actually squaring that. So you have to remember you're going to square that. So we get 2 times, that gives you a squared plus 2ah plus h squared. Distribute the 2. That's what you should do next. And you get 2a squared plus 4ah and plus 2h squared. Remember, subtract them. Subtract f of a plus h and minus f of a, and then divide it by h. So f of a plus h will be 2a squared plus 4ah plus 2h squared minus 2a squared. Divide the whole thing by h. The only thing that cancels is the first term and the last term, which will leave us with 4ah plus 2h squared divided by h. Some people were making this mistake on the quiz. They were just canceling one of the h's. Remember, you have to factor out an h first. So on top, when I factor out an h, I get the following: a 4a plus 2h, divide that by h. Now you can simplify the h's, and your final answer will be 4a plus 2h. Finding the vertex form. Remember, here we have to complete the square. So to do that, we have to follow the steps we did when we're completing the square in chapter 1. So let's go ahead and start there. So we're going to begin with making this x squared minus x. Remember, bring the 20 to the other side, so now it's actually positive 20. To get that third term, I'm going to divide that by take b, divide that by 2, and then square it. So when I take -1, divide that by 2, that's going to be -1/2. -1/2 squared is actually going to be +1/4, which means I'm adding 1/4 to the other side as well. So this will give me x minus 1/2 squared is equal to, if you want to do 20.25, you can. So we can keep it as a fraction, or we can keep it as a decimal. Really does not matter. I'm going to keep it as a fraction since my other term is a fraction as well. So it'll be 20 and 1/4, not 1/2. So make it as a mixed number. Now bring that back to the other side. So bring that back to the other side, and we get the following. F of x is equal to x minus 1/2 squared minus 20 and 1/4. So let's talk about what the formula is. So the formula is going to be f of x is equal to x minus 1/2 squared minus 20 and 1/4. So that's a vertex form. B says state the vertex. In other words, write it out. Remember, inside lies, so it's actually 1/2 and then negative 20 and 1/4. That's your vertex. To find the x-intercept, remember what we said. To find the x-intercept, we have to set y equal to 0. And to find the y-intercept, we set x equal to 0. And from there, we'll be able to figure out what those values are. Now, in our first one, we can set y is equal to 0, so we get x squared minus x minus 20 is equal to 0. First question you should ask yourself, can you factor that? Are there two numbers that multiply to negative 20 and add up to negative 5? And it does look like we do have. We have negative 5 and positive 4, which means x is going to equal to positive 5 and negative 4. So that will be my answer. X is equal to 5 and negative 4. On the other side, we will have y is equal to 0 squared minus 0 minus 20. So y is equal to negative 20. So y is equal to negative 20. Now notice it says graph, it's not saying sketch, so you actually have to put a little bit of effort to make sure you give us a pretty good value for each one. So let's go ahead and do that. So we know what our vertex is. Our vertex is 1/2 and negative 20. So, and again, you can break that up. You can break the sections by 5s. You can make them 10s, whatever you like. Looks to me like the best one that would work for me is by making them maybe 5s each section, because negative 20, that means I have to go down 20 units. And again, you won't have a perfect at negative 20 and 1/4, but you should be pretty close. So you should be definitely creating a table for this, because we want to know some values. So the one that's going to be right here in the middle of the table is always going to be the vertex, which is 1/2 and negative 20 and 1/4. If I have 1/2 in the middle, the best bet that I can do, or the things that I can do, is I can choose this to be 0, and I can choose this to be, let's say, 1. That will make it a little bit more easier for me to graph. Now I'm gonna make x's go up by 1 unit, and my y's are gonna go up by 5 units. So what I'm trying to say here is each square on the y-axis is 5, but each square on the x is just going to be 1, so it'll be easier for me to graph that way. So if I plug in 0, so again x is 0, I get negative 20 as a result. If I plug in 1, we get 1 minus 1, and again that will give us negative 20, and it should. Now that's not enough information, so what we need to go a step further. We need to make this 2, and we need to pick like negative 1. So let's plug in negative 1. Negative 1 squared will be that positive, so it'll be 2, so it'll be 18, negative 18. And this will also give us negative 18. So that should give us enough information to graph that. So let's go ahead and do that. Vertex is 1/2, so half will be here, and then it's going to be 5, 10, 15, 20, so it's going to be just under the negative 20 there. So I'm going to go ahead and put that negative 20 there. At 0 it's negative 20, and at 1 it's negative 20. Now at negative 1 it's 18, so it's going to be just, remember this is 10, 15, so it's just somewhere here, and it's going to be somewhere here. And so that should give me enough information to graph. As you can see, it's going to be a wider parabola, and so you would graph that way. When you're graphing this, I expect to see a couple of things. I want to see the x. Actually, let me go do this. I expect to see the x-intercepts, so that would be 1, 2, 3, 4, 5, and 1, 2, 3, 4. So I have to go through there. I do expect the y-intercept to be at negative 20, and so those are the main things I'm going to be looking for. That you make sure you go through those points, and you have a table that kind of gives you an idea what the graph should look like, or what the parabola should look like. So the last 3 problems we're going to look at is going to be given by the following. So let's go ahead and look at, we have to first find the f of negative 1, which is the inverse, and then plug in 2. So let's find f of negative 1 first, or the inverse. Remember, step 1 is to change the f of x to y, so we get y is equal to 3x minus 1. Step 2 is to switch x and y, which gives me the following. And step 3 would solve for y. I'm going to move that, so I'll get y is equal to, I'm going to skip a couple of steps here, but you should be able to follow along. If you need to, you can look at this video later and figure out what happened. But again, I'm solving for y, and this gives me f of the inverse function of x is equal to x plus 1 divided by 3. Now I'm going to take that f of the inverse function, I'm going to replace it with 2, and I get 2 plus 1 divided by 3, which gives me 3 divided by 3. Therefore, I get 1 as a result. Similar steps are going to be taken here. First thing, replace f of x with y. That gives me 4x minus 1 divided by 7. Then switch x and y. So that gives me 4y minus 1 divided by 7. Multiply by 7 on both sides. So times 7 times 7, so these can simplify, cancel out. You get 7x is equal to 4y minus 1. And then if you continue with that, you get y is equal to, again, move the 1 to the other side, so that gives you 7x plus 1. Divide by 4, so you're going to divide by 4. And that gives you f of, or the inverse function of x is equal to 7x plus 1 divided by 4. So now I'm looking what's f of 2, or the inverse function of 2. So when I plug that in, I get 7 times 2 plus 1. Divide that by 4, which in turn gives me 14 plus 1 divided by 4, and that gives me 15 divided by 4. As I cannot simplify that, there is no number that goes into 15 and 4 at the same time, I can leave my answer 15/4. The other couple problems that you will see on the test as well, it will be sketching the piece functions. So remember, there are 3 functions here. There are 3 functions. And as you recall, I said that if it's just a number, then it's going to be horizontal lines. So notice my domain restrictions. The first one has to be at -2, so x has to be -2, but it cannot equal to -2. So when I graph this function at -2, I'm going to have an open circle, and at +3. So notice I have to go at -2, +3, I'm going to have an open circle, and I'm going to go this direction because x has to be less than -2. At -2, it says x is greater than or equal to, so it actually equals to -2, and it's at -3. So I'm going to have my horizontal line at -3. I have a closed circle, and it's going to go all the way to +2, and I'm going to have a closed circle at +2 as well. And then after +2, as soon as you pass +2, it's going to jump back up to +3 with an open circle, and this time it's going to be going this direction. So your graphs would look as follows. If you have any questions or anything like that, again, please watch the video. It will be posted online, and that way you can review and go back and relook at any problems that you have questions on. Hope you guys have a wonderful day, and good luck on your test.